Welcome to this important video of Python built-in functions in which we are going to discuss an important built-in function which are called trigonometric function. Let me review that built-in functions are those functions which are already defined in Python. So we do not need to use them again. We do not need to define them again. What we need to do is just we need to call them whenever we want to use them. Built-in functions are stored in math module of Python, which means whenever we want to use them, then we need to import this module which is called math. So first built-in function is degrees. This function is used to convert the value of angle x from radian into degrees. Another built-in function is radian, which is needed to convert any angle from degrees into radians. Next built-in function is cos, which is used to find the value of cos. Similarly, next built-in function is sine, and similarly next built-in function is tan. In this case, the angle x is in radians. If the angle is not in radian, then it will give us a wrong value. So it should be clear that any value written within sine, cos or tan or any angle is in radian. So let me use this at Python software in which we can see. I am going to open the PyCharm, which is the Python developing environment. However, you can use any developing environment to write code in Python. First of all, we have imported the module for trigonometric functions because this is the math module in which trigonometric functions are also stored. Next, we will use a value x which is pi by 4, and next we will use this value to find the tan, and then we will run the code, and you can see here this tan pi by 4 which is tan 45, this is equal to 1 which is 0.999. So in this way, this is the way to use the function. Similarly, we can find the sine value of this x, in which x is in radians. Now we will use simply run it, and we can see here is 0.707 approximately, and again cos 45 or cos pi by 4 is also equal to 707. So again it is equal to this value. Next, what we do, we can use here degrees. When we use here degrees, then it will convert the value of x which is in radian into degree. So I am going to run this code, and you can see here the value of x which was pi by 4, it is equal to 44.977, which is approximately 45 in degrees. In this way this code works. So some other important trigonometric functions which are built-in functions are inverse functions like a sine x, a tan. Whenever we want to perform the inverse operation like sine inverse x, tan inverse x, then what we need to do in Python, we simply write a before sine x, and this is used to perform the sine inverse function. Similarly, to perform tan inverse x, we write a tan x, similarly a cos x. So last function is hypotenuse. It is used to calculate the hypotenuse. For example, we have a triangle which is given. In this case, base is x and perpendicular is y, and we want to find the hypotenuse. Then what will we do? We simply use this function hyp. It will calculate from Pythagoras theorem, that it will calculate as x square plus y square and square root. So these are some important trigonometric built-in functions which are stored in math module. Let me use this again from our code. So I'm going to run this code in such a way that I'm going to perform first sine of x. You can see here the output of sine of x is 0.706. Now I'm going to perform z2 is equal to math dot a sine of x. Will it do? It will perform now inverse function of z. So it will again return us the previous value. So this is the way to execute, and we can see here is the output 0.707, which was initial angle. Okay, so in this way it works, and this is the way to use the inverse function. So let me write here another code which is hypotenuse. For example, we have two numbers, one is x which is 3 and other is y which is 5, and we want to calculate the hypotenuse from x and y. Then what will we do? We will use the module name first, math, and then hypotenuse, and then we will print this value. We can see here it is given as in such a way that it will display the result, and it should be, here is the spelling mistake, and we can run it again, and you will see here this is the result. So in this way the output is displayed for trigonometric function, and this is the output. Thank you so much. That was all for this. We will cover next built-in functions in the next lecture.